Welcome back. Tonight we're going to be taking a look at factoring trinomials, specifically using box method. Now this method is going to come really in handy later on for Algebra 2, understanding certain concepts, and that's why we're going to illustrate this using box method. As some people think this is easier than other methods for factoring. It's a little more intuitive. Okay, and for this we're going to be factoring the trinomial x squared plus 7x plus 10. Now, there's another special word for this trinomial, and that's going to be a quadratic. This is actually a quadratic equation, and most of the time when you are factoring, you're going to be factoring quadratics, in Algebra 1 especially. Now, remember, anytime you're doing this, you need to make sure, the easiest way to do it is to make sure that your quadratic is in standard form, and that is where you have ax squared plus bx plus c. Okay, the first term is going to be the x squared term, the second term is x, and the third term is c. You just order it by highest exponent to smallest exponent. Okay, so let's take a look at factoring this x squared plus 7x plus 10. Now, in order to use the box method, we're going to go ahead and draw the box. Again, trinomials are usually the result of two binomials being multiplied. So when we're factoring it, we're going to make a box that is 2 wide and 2 high. Okay? And we know that this first term is the result of this first top left box, always. Usually, when you do this, that's what you're going to get here. So every time in Algebra 1, that's what we're going to put there. It's the x squared term, that first term. Okay? And we also know that this last term, the number term, is always the result of this last box. So we're going to go ahead and fill that in. Now here's the trick. If you remember back to multiplying polynomials, if we look at this example that we pulled from that, these awkward boxes here, these two, they're going to be a result of the term in the middle. They're going to be the terms that combine. And that's why sometimes this can be a little difficult, but we make it easy. So let's go ahead and set up a factor table, because I need to figure out what these two terms add to, what two terms add to get 7, and multiply to give me my last term, 10. Okay, so let's go ahead and set this up. On top of this factor here, I'm going to multiply my first term, the x squared term, and my last term, the 10 term. Okay, and x squared times 10 is just going to yield 10x squared. Okay, and that's what I'm trying to find factors for. Okay, I'm going to find factors for 10x squared, things that multiply to give me 10x squared. And every time I do this, this x squared is going to be shared between the two. So you'll always have 1x with one term and 1x with the other. Now let's start listing off factors of 10x squared. The first one, and the one often forgotten, is going to be the 1 and 10. Okay? And those do multiply to give me 10x squared, but they don't add to give me 7. Okay, 1x plus 10x is 11x. So keep going. 2x, 5x. And then I think that's the last set. So let's go ahead and keep going. 3, no. 4, no. 5, well, yes, 5 gives us 10 multiplied by 2. But see how we're just repeating previous ones. Okay, and the last one you're going to get is 10x and 1x. And we want to know which of these adds to give us the middle term here, the 7x. We discussed earlier that this is going to be 11x, so that one's not going to work. What about 2 and 5? Well, yeah, that's going to give me 7x. So these two terms fulfill both the requirements. They multiply to give me 10x squared, and they add to give me 7x, our middle term over here. So I'm just going to put them in the box. It doesn't matter which order you put them in, either one, either way, because this next step will correct for that. So go ahead, I'm going to put the 2x here and the 5x there. Okay. Now, if you remember multiplying polynomials, we started with these two binomials here. Okay, and where did they go? Well, they went on top and down the left side. And we're going to kind of do that in reverse now, because now we have everything inside the box, and we want to know what's outside. Okay, so let's do that in reverse. I know I'm going to get something going here, something here, something here, and something here. In order to get what goes in these 4 spots, I'm going to be looking for common factors, or specifically the greatest common factor. Okay, and that will work every time. So if I look to get this top box here, I want to look at the 2 things below it, what we use below it to get that. So what's the greatest common factor between x squared and 2x? And I know that that's going to be an x. There's an x in both of those, so that's going to be my greatest common factor. Okay, and let's look here, 5x and 10. Now what's my greatest common factor there? There's not an x in both, but there is a greatest common factor. And it's going to be 5, positive. Okay. Now to get the ones down the left side here, I'm going to figure out what the greatest common factor is in my row. Okay, not in the column, but in the row. So looking at, for this space, I'm going to find the greatest common factor, my GCF, of x squared and 5x. And we'll find that it's, again, x. Okay. And then here, to get this space, I'm going to figure out what's the greatest common factor between 2x and positive 10. And you'll see that that ends up being positive 2. Okay. So now that we have what goes across the top here and down the side, we're just going to write those binomials. Okay, x plus 5 and x plus 2. And that's going to end up being my answer. Okay.